Solar power has long been seen as a key to our sustainable future, but researchers have been constantly pushing the limits to make it even more efficient, lighter, and durable. Now, an exciting breakthrough in solar technology has emerged: ultra-thin perovskite solar cells. These aren't just any solar cells, they harness a cutting edge design that's not only more efficient but also more resistant to harsh environments. And the secret, a clever light trapping trick that's boosting efficiency to new heights. At the heart of this revolutionary innovation is a special light trapping trick. Researchers from Nova University of Lisbon have developed an ultra thin solar cell that combines two key technologies: a checkerboard light trapping design and a luminescent downshifting encapsulant. Together, they achieve something incredible: a 28.2% high photocurrent, making these cells some of the most efficient we've ever seen. Let's break it down. The first trick is a checkerboard light trapping design. You see, when sunlight hits a solar panel, not all of it gets absorbed. Some of that precious light bounces away. But this checkerboard pattern, it's a game changer. It scatters incoming sunlight in a way that keeps the light bouncing around inside the solar cell longer, giving the ultra thin perovskite layer more time to absorb it, even when the light hits at odd angles. The result? A massive 25.9% boost in photocurrent, all from a layer just 250 nanometers thick. That's thinner than a human hair. But there's more. The second breakthrough is in a material called luminescent downshifting, or LDS. In simple terms, this technology takes harmful ultraviolet UV light, which can degrade solar cells over time, and converts it into visible light, a form of light the solar cell can actually use to generate electricity. Thanks to this, the LDS encapsulant not only improves efficiency but also protects the cell from UV damage, converting 94% of UV radiation into usable energy. This makes these solar cells especially exciting for space applications. In space, where UV radiation is at its most intense, typical solar panels degrade quickly. But with this LDS layer, perovskite cells can last much longer while maintaining their high efficiency. Think of it: lighter, thinner, and far more durable solar panels powering our future mission to space. With these two innovations combined, the researchers have crafted a solar cell that is not just efficient but also incredibly versatile. Whether it's spacecraft, satellites, or portable solar chargers, these ultra-thin perovskite cells can do it all. And with their lightweight design, they're perfect for applications where size and weight matter most. Even better, these cells are resilient to manufacturing defects. That means they can be produced at scale without losing efficiency, making them a highly promising option for the future of commercial solar technology. Imagine a future where these high-efficiency, ultra-thin solar cells power everything, from the buildings we live in to the spacecraft exploring new worlds, and even the devices we carry in our pockets. It's a vision that's closer than ever thanks to these breakthroughs in light trapping and UV protection. If you're as excited as we are about the future of solar technology, don't forget to hit that like button, share your thoughts in the comments, and subscribe for more incredible tech breakthroughs. The solar revolution is just beginning.